Welcome to Biology of Marine Mammals. I'm Dr. Leslie Williams, and this is the second lecture that covers marine mammal reproduction. In this lecture, we continue to explore the challenges that marine mammals face by trying to reproduce in the water, and we're going to take a look at gestation times, birth, and lactation as examples. So to quickly recap, we previously went over several different reproductive trends in mammals. These apply to all mammals, including terrestrial mammals. And in this lecture, we're going to look at some of the challenges that are associated with gestation, particularly gestation length, or how long a female carries an embryo and fetus. And then we'll take a look at the challenges of live birth in the water. And then finally, the fact that females must lactate or produce milk to nourish their offspring. So let's start by actually taking a look at some gestation periods for terrestrial mammals. Now what we want to do is we want to correlate the size of an animal with how long their gestation period is. So on this slide you can see that I have mammals ranging from a very small hamster to the very large elephant. And hopefully if you take a look at the length of gestation, you start to notice a very strong trend. The larger the organism, the longer the gestation period is. So humans, for example, have about a 9-month gestation period, but elephants really take the cake with their extreme gestation period of 21 months, whereas a tiny hamster only takes about 20 days. Now, why is there this strong trend? And the answer has to do with the fact that we start with a very small fertilized egg. So no matter what species you are, a hamster or a blue whale, you always start with a fertilized egg that is microscopic. And then you have to allow that fertilized egg to go through a series of cell division and development. Well, only so much development can happen in a set amount of time. So for example, by 6 weeks of development, you could actually have a hamster that's already been born and that you can hold in your hand with fur. So they're actually born without fur and then they develop their fur later. Or you could have a human embryo about the same size, something that could barely fit in your hand. Well, what about 9 months? By 9 months, you can have almost a full baby. I'm actually 9 months pregnant, so you can see it takes 9 months to build something of this size, or you could have potentially an elephant fetus of about the same size, maybe a little larger. In other words, by 9 months of development, you expect to have an organism of about this size, give or take, a little bit more or a little bit less weight. So how long do you think it takes some of our largest marine mammals to gestate? Well, you might start thinking, oh, it's going to take 4 or 5 years for them to build up these big calves, but you'd be surprised. Cetaceans in particular buck the trend, and this is particularly true for the mysticetes or the baleen whales. Amazingly, cetacean gestation time ranges from 10 to 12 months. What? That's amazing. How is it possible that it takes an elephant 21 months, but it takes a blue whale 11 months to go from the microscopic fertilized egg to a 2.5-ton calf, which, by the way, is about 5,000 pounds and also 23 feet long? How is that possible? Well, amazingly, it is possible, and it's also necessary. So what we're going to look at is, what does it take for a cetacean to actually be able to build a huge newborn in such a short amount of time, and why is this necessary? All right, so let's start with the necessary reasons, because clearly there's got to be a good reason or they wouldn't be doing this. And the answer is that gestation needs to be tied to an annual schedule. You may recall that mysticetes have feeding grounds in the summer, and then a lot of them migrate to an area to give birth. That has to stay on an annual schedule or they're going to get off by the seasons. So because they tend to go to a birthing ground or a breeding ground at a certain time of year, that needs to be when they give birth. So annual time cycles are of course 12 months, so it makes sense that a gestation time of 11 months would be the norm. So because you're trying to tie into this optimal annual schedule, you have to basically go from a fertilized egg to a huge fetus and therefore a newborn in a very short amount of time. The way this is done is by allowing the pregnant mother to divert pretty much all of her resources into that growing fetus. And so, for example, as I mentioned, I'm 9 months pregnant. So when I eat, I probably still take about 80% of my food for myself and only take maybe 10 or 20% of my food and divert it to my almost newborn. A whale wouldn't do that. A whale would take almost everything that they eat and divert those resources right into the newborn so that the newborn could grow rapidly. So clearly, what this shows is that the mothers have got to have good access to food supplies in order to support their rapidly growing fetus. Now, interestingly enough, if you look at a species of cetacean that doesn't show migrations, like the sperm whale, they are not under that pressure to be tied to an annual schedule, and therefore they tend to show longer gestation periods. So sperm whales, for example, have a gestation period that's more like 15 to 16 months. In other words, they're going to take longer to build their fetus. They're going to do it a little bit more slowly because they're not tied to an annual schedule. Now, also interesting is that many of these baleen whales only breed every 2 to 3 years. So they spend a year gestating, they spend a year caring for their newborn, and sometimes they take a year off because it's so energetically taxing to their body to basically say everything that I've ever made is going to be devoted to this new fetus, and then as soon as they come out, I'm going to produce a ton of milk to help that newborn come and grow, and then I need a year off in order to recoup and rebuild my own reserves. So what about pinnipeds? Now, when we look at the pinnipeds, we also notice that a lot of pinnipeds breed on an annual schedule. For example, the northern elephant seals tend to breed in early and late winter. So this also means that these species are going to be tied into an annual gestation period, which means the gestation actually lasts around 11 months. Now, what's also interesting is that the pinnipeds don't actually seem to need that long to fully develop a fetus from a fertilized egg all the way to a newborn. And so most of them, in fact, I think all of them, use something called delayed implantation. What this says is you take an egg, you fertilize it, and then you basically just hold on to that fertilized egg for 3 or 4 months, and then finally allow it to implant in the uterus, where then it will start taking nutrients from the mother. And this will then keep the gestation cycle on an annual cycle rather than saying it takes 8 months to go from a fertilized egg to a newborn, and therefore you get off on your annual cycle. Every 8 months would not put you on a seasonal winter breeding month period. All right, so now that we've finished with gestation, let's actually turn to birth and lactation in the water. Now, pinnipeds have the advantage of being able to give birth on land, which is good because the newborns need to breathe. Cetaceans and sirenians do not have that option. They are forced to deliver their calves or their pups in the water, unfortunately. Now, you might imagine that the birthing process isn't particularly fast. And so because of that, it's not advantageous to have the head come out first, as it does, for example, in humans. And this is because if the head comes out first and the calf tries to breathe and the cetacean is still underwater, then the calf could actually drown while waiting for the rest of the body to emerge. So cetaceans are actually delivered tail first. In fact, interestingly enough, when you go back and you look at fossil records of earlier cetaceans, which were amphibious, one of the things that is interpreted as being a land birther is the fact that you have a head first delivery. So earlier cetaceans used a head first delivery, and this was interpreted to mean that they actually were delivering their babies on land. So again, we have a tail first delivery for cetaceans. Now, lactation in the water is also challenging, in part because you've got a bunch of milk that you're trying to get into this newborn, and if you miss, it ends up just getting diluted in the other parts of the sea. Also, if you've ever seen, or if you could imagine a newborn whale, you could understand that their mouths are not very pliable, and therefore they are not very good for sucking. So for example, human babies have a lot of muscles right here in their cheeks that allow them to get a nice good suction on mom's nipple so that they can breastfeed. Whales don't really have that. They don't have that mouth movement that will allow for a sucking. So obviously lactation in the water is also a challenge. All right, so what is it that we do for pinnipeds at birth? When we take a look at pinniped birth, all pinnipeds give birth on land and allow for a continued care of the newborn on land or ice, because some pinnipeds give birth on ice, as well as throughout the lactation period. So interestingly enough, this actually poses its own challenges. Even though we might say, well, we're on land, what challenges are there? Remember that pinnipeds need to go into the sea in order to eat. And so if you're a mother that's coming out onto land and giving birth on land, then you have an issue of needing to feed yourself, or maybe not feed yourself, during that period of time to allow for both your survival and the survival of your pup. So interestingly enough, this has also resulted in some really interesting lactation solutions. So when you have a breeding habitat that is really unstable, such as ice, so a lot of pinnipeds will give birth on ice, then you have a problem of the fact that the ice might actually break up. If you are a pinniped that comes out onto land and you don't feed during any time of that lactation period, then you risk basically starving or dehydrating yourself during the lactation period. So you might think that lactations are going to be, just like human lactation periods, ranging from 6 months to up to 3 years long for the pinnipeds. But many, many pinnipeds employ very, very short lactation periods because the female either needs to hurry up and get it done so she can get out there and eat, or the ice is going to become unstable if they're breeding on ice, and therefore the pup could actually fall down. The pup just needs to grow as much as possible. So when we take a look at lactation length, the champion lactation length is actually 4 days. So one species of phosid only uses a 4-day lactation period. And what you're trying to do during these really short lactation periods is get the pup to grow as much as possible during that short amount of time. So what does that mean? Again, that means a huge transfer of weight that you're trying to go from mom to the pup in order to ensure that the pup is going to be large enough to be able to survive on his or her own when the mom leaves. So one of the solutions is to use a very fat-rich milk. So phosid mothers, for example, which tend to lactate for very short periods of time, use a milk that usually exceeds 50% of fat. As a reference, human milk is about 4% fat. So is cow milk. So if you ever buy whole cow milk, it's about 4% fat. Now, otariids don't usually have those problems. First of all, the mothers usually feed during the lactation period. So they're not trying to basically cram as much food into the pup as possible in a short amount of period of time because they're still able to eat. Also, because otariids stay away from the polar areas, they're usually breeding on land, not on ice, so they don't have to worry about the instability of the land and try to get their pups off of it as fast as possible. And so this usually results in much longer lactation, ranging from months to over a year. So for example, a standard otariid might lactate for 9 months, a year, something more similar to a human. They simply aren't faced with the same challenges that phosids have in trying to either fast during their lactation period or get their pups off ice that might become unstable at any moment. And that concludes our lecture for looking at some of the reproductive challenges that marine mammals have dealt with, and I will see you next time.